certain answer. For example, at the some point you don't know how to reduce it. Okay, you don't know what the formula should I use at this particular point to reduce it. On the other hand, there is another person who is solving the same problem but know how to use the formula or the rules, you can say, and minimize it to one more step. So the answer obtained by you and that particular person is different. So that's why we cannot say that the answer is minimum by using the Boolean algebra. And also, it's quite hectic and tough to solve the Boolean algebra as compared to the K-map. However, it is easy practice to do. So these are some reasons because of which we will switch to the K-map. It's very easy, less time consuming, and also the result is minimum. Okay, it is minimum but not same. We will see examples in which the result is minimum but it is not same. So that's why a K-map is a very vast thing in the digital electronics and almost used in every topic, you can say, to minimize the circuit or to obtain the circuit from the given logic. That's why this lecture is very important, and without wasting any time, let's move to the K-map. But before moving to the actual K-map, let me make a truth table for the function. Let's say the function f, and it is given as a or b c bar. Okay, this is the function given to us. We will first make a truth table by using this function, and we will obtain the same function a or b c bar by using the K-map. This proves that yeah, we can get the minimized result from the K-map in a much easier way. So let's start making our truth table first. So as you can see that I'm having a, b, c, three variables involved. So a, b, c are the three variables, and you very well know that when we are having the three variables, there are possible 8 combinations. So let me write down the 8 combinations. If you already know how to do this, then I want you to do it by yourself by pausing the video. 1 1 1 and 1, 0 0 1 1, 0 0 1 1, 0 1 0 1 0 1 0 1. Okay, so these are the possible combinations. Now we have to see for which values of a, b and c by putting in this function the value of function f is true. Okay, so f given here is true. So as you can see that when a, b and c are 0, the function is 0. When a, b are 0 and c is 1, the function is 0 again. Okay, when a is 0, b is 1 and c is 0, the function is 1, because this thing will be 1. B is 1 and C is 0, so complement of C will be 1. 0 or 1 is 1. And when A is 0, B is 1 and C is 1, it is 0. And for all the other cases, it is 1, because A is 1 for the last 4 cases. And something odd with 1 is always 1. So this is the values of f. Okay, now what we can do, we can form you can say canonical sum of product from this truth table. So let's make it f is equal to, we will see for the values of f which is 1, so it is a bar b c bar, a bar b c bar, or a b bar c bar. Similarly, a b bar c, a b c bar, a b c. So this is the canonical sum of product, and by using the Boolean algebra we can minimize it, and we can get this function a or b c bar. So you can see that it's very laborious to minimize this big function into the function that we got earlier. Okay, so by using the K-map, can we reduce it? Let's see. First, let me reduce it by using the Boolean algebra. Okay, so what we can do, we can take a b bar common here. So a b bar common here. So we are left with c bar or c common here, a b. So we are left with c bar or c. Okay, so a bar, b c bar, or a b bar, or a b. B. So that should also be 1. So I'm having A bar, B, C bar, or A. Now by using the distribution law, I can write it as A or A bar, B, C bar. Okay, let me write it down directly because I have already explained the rules and we will use that. A is here, A complement is here, so I'm going to write as A or BC complement. We will neglect this A complement. If you don't know how I am doing this, then please refer to my earlier videos because we are not going to waste the time in these all things. After all, we are here for the K-map. So as you can see that these steps are involved in getting a reduced form of the function by using the Boolean algebra. So now let's see what we can do by using the K-map. So let me do one thing, is to make a cell here, and as there are 8 combinations for 3 variables, I'm going to make 8 cells. All of them are same in size, okay, and each cell corresponds to this combinations. Okay, so we are left with 8 cells, and the cell number 1 is for, let's say this is A, here we are having BC. So cell number A is for when A is 0 and BC is 0, 0. You can say A is 0 and BC is 0, 0. So this is cell number 1. And we also know that we write it as M0, the min terms, M1, and this is the small m, M3, M4, M5, M6, and M7. So let's say this cell is your M0. Similarly, this cell is your M1. Here A is 1. Sorry, A is 0 and B is 0 and C is 1. Similarly, this is M2, A is 0, B is 1, C is 0. This is M3, A is 0, B is 1, C is 1. M4, A is 1, B is 0, C is 0. M5, A is 1, B is 0, C 1. M6, A is 1, B is 1, C is 0. And then M7, all the 3 A, B, C are 1 in this case. So this is our cells. Okay. Now we will arrange this cell in such a manner so that the corresponding cell, or you can say that the neighboring cell, is having only one variable changing. Okay. I know it sounds a bit confusing, but let's see how we will do it. I'm making the M0 here. Okay. And I will keep all these cells M0, M1, M2, M3 in the same line so that A is 0 for all of them. So let's say this is M0, this is M1. Okay, the 4 cells. Here A is equal to 0 for all of them. You can see for M0, M1, M2, M3, A is 0. So I have just connected them and kept A is 0 for all of them. Now we will see for B and C. BC, we will see BC. Now for the M0, you can see BC is 0, 0. So this is 0, 0. For M1, the BC is 0, 1. Okay. Now you can see that in M0 and M1, only C is changing. The C is 0 here. Now in M1, C is 1. Whereas A is 0 for both of this and also B is 0. So this is what we have to do in K-map. The adjacent cells have only one variable changing. Okay, we have to change only one variable in the adjacent cell. There is a very proper reason for this that I will give you after some time when we will make this complete cell. Now you can see M2. M2 is what? 0, 1, 0. So A is already 0 for this cell. But if I make BC as 1, 0, as in case of M2, you can see that C is changed from 1 to 0. At the same time, B is also changed from 0 to 1. So the two variables B and C both are changing. This is against the rule of the K-map. We cannot change the two variables in the adjacent cells. So we cannot take M2 here. Okay, it's very obvious. We will not take M2 here, but we will take M3. Why M3? Because in case of M3, the BC is 1, 1. So you can say, or you can see between M1 and M3 that only B is changing from 0 to 1. C is same, 1, 1, and A is 0. So this is the very important point in the K-map that we have to keep in our mind, and this is called the rule of adjacency. The adjacent cell have only one variable changing. That's why we have not taken M2 here. We will take M2 here, and M2 is what? 1, 0. Now you can see between M3 and M2 only C is changing from 1 to 0, whereas B is same 1, 1, and A is already same for all these cells. So this is how we will make the first row. Now we will move to the second row in which A is equal to 1. There are 4 rows. Okay. Again, we will arrange by keeping in mind that we should not have the two variables changing in the adjacent cells. Now 1, 0, 0. 1, 0, 0 is what? 1, 0, 0 is your M4. BC is 0, 0 for this cell and A is 1. Similarly, A is 1 for this cell and BC is 0, 1. So this is M5. And A is 1 for this cell and BC is 1, 1. It means M7. Again, you can see here we don't have M6 because in case of M6, the two variables are changing in the adjacent cells. So we cannot take it, and it will be now M6. Now this is how the map, or you can say that the cells of the K-map is been arranged. I know in the schools, in the colleges, when they teach you the K-map, they just draw this thing. However, they start from the 2 variable. I have started from the 3 variable, no problem. They just take these cells, okay, and to fill it like 0, 1, 2, then 3, 4, 5, 6, then 7. Okay, and you just mug it up and fill the cells in the same way throughout your life, but you don't know what actually is going inside it. That's why I made this lecture very precisely, so that you can understand this all things actually going on here. Now you might be thinking that Sujit, you just told us that yeah, we have to make the cells and arrange it in this form, but why we are doing this? The main reason is that we have to use this property. We have to use a very important property that we learned in the Boolean algebra, is that A or A complement is equal to 1. Okay, we are using this property in these cells. Let's see how. And remember, the consistency also follows in this way and also in this way. Okay, it means when you compare M0 and M2, and M0, you will find only one variable changing. Let's see, the A is same and also the C is same. C is 0 here, C is 0 here. So A and C are 0, 0, but B is changing from 1 to 0. Similarly, if you compare M2 and M6, you will find R and C same 1 0. Sorry, B and C same 1 0, but A is changing from 0 to 1. So adjacency also follows. This is called as the rolling of the map, or you can say the map rolling. Okay. So the adjacency follows between the two adjacent cells in this way and in this way, and also between the two end cells. Okay. In this way, these two are same and these two are same. Not same means the two variables are same, one variable is changing. So this is all about the map formation. Now we will see why we do this, and we will see the reason by.
Okay, guys, we'll continue this in the next practical. Okay, guys, just give me your roll call. Okay, roll number 1. Roll number 2. Roll number 2. Roll number 3, present. Roll number 5. Roll number 6.
Yes, sir.
Okay. Roll number 7. Roll number 8. Roll number 9.
Present, sir.
10. 11. 12.
Present, sir.
Okay. So roll number 8, roll number 5, roll number 2, and roll number 1 are absent.
Sir, 8 was there, sir. She just now
Okay.
disconnected.
Okay. Roll number
So
8
13
present.
present.
Okay.
Sir, roll number 13 present.
Roll number 13.
Yes, sir.
What's your name?
Venkatesh.
Okay, done. Well, guys, see you all. Take care. Bye-bye. No problem.
Thank you, sir.
Thank you, sir.
Yeah, thank you. Bye.